Good evening. Welcome once again, all the minions, all the V enthusiasts, to the next lecture of modern physics, where we are going to talk about atomic structure and X-rays. I'm pretty sure you have some idea about atomic structure from chemistry, but we're going to see some really cool problems related to physics in this particular chapter of atomic structure. And don't worry, in case you have forgotten the formulas, I'm there to make sure that you revise everything, recollect all the theory before we begin with some previous year problems and some really interesting questions. And of course, we are also going to talk about X-rays, the Coolidge tube, and also Mosley's law in today's session. So if you are ever scared of X-rays, and it was one of the dreaded topics, so don't worry, you are at the right place. And all this with me, Shreyas, your master teacher for physics at Vedantu going live. Hello everyone. Hello Randy. Hello Aishwarya. Hello Kirito. Wow, nice to see you back. Hello Nirupam. Welcome about all the V enthusiasts out here. So guys, this is Shreyas here, and I teach not only on Enthuse, which is a very special channel dedicated for all those aspiring students who want to crack the engineering entrance examination in English medium, because I don't see many channels out there doing all this great work in English. So we decided to get together and make sure that we are able to teach as many kids as possible in English who want to crack JEE, boards and other such competitive exams. And I have been training not just in online, but in fact in offline before I joined Vedantu. And many of my kids, not just before, but even this year, have cracked JEE with really amazing marks. Many of the students have even got 2-digit all India ranks in JEE mains as well as advanced. And that's the whole point, guys. I'm here to make sure that you learn from me, from the best, so that you also can reach and touch the skies one day. Hello greats. Hello Saurabh. Hello, welcome Nirupam. Hello, good evening. I hope you guys had your dinner. And in case you want to get to know more about me and want to see all my updates, you can do so by following me on Instagram, Shreyas_Vedantu. That's my Instagram handle. So do check it out. And before we begin, yes, you need to smash that like button out there. Go ahead, because that's the cost for attending today's class. So go ahead, do that right away. And do not forget to hit the subscribe button if you are very new to this channel, because the only way you can get all the important updates, all the important news and all the important lectures, theory, mock tests, etc. and everything related to JEE, our boards and other such examinations is by hitting that subscribe button. The best part is it's free of cost. Hello Swati, welcome all the new members. Hi Ravindra. Welcome. Hi Santosh Kumar. So I would really like to welcome all the new students out here. Thank you Swati so much. And remember guys, you can introduce yourself, make new friends. Many of the students out here already on the chat box are very regular students. So nice to see all of you out here, and even the new students. And by the way, this is the timetable of this week. So if you have missed any of the waves classes, you can go ahead, check it out in the playlist. You can get every detail of transverse, longitudinal, electromagnetic, standing waves, YDSC and all that. Hi Charisma, welcome. Hi Vignesh, good evening. I hope you had a lot of dinner and you guys are stomach full now, all excited for this lecture. I started with modern physics yesterday, photoelectric effect and photons. Today is atomic structure and X-rays. Tomorrow, do not forget, it's at 7 o'clock, nuclear physics, and something special coming up for all of you on Valentine's Day. So stay tuned guys to know more. Okay, so let's begin with our class. I hope everybody is ready. Yes, and keep making notes, do not forget. Very good Nirupam, excelente. So guys, who are these people? These are the great people who modeled atom by their discoveries, their observations and experiments. So Bohr, J.J. Thomson, Rutherford, very famous scientists who gave us the idea of atoms, and everyone proposed some kind of models of atoms. In fact, there are more people, but I'm not fit in all those people out here. But understand, everybody gave the model. In JEE, the model that we have to study is the Bohr's model of atom. Keep this in mind. But even Bohr's model is invalid because it is not so precise and there are so many other problems when you apply Bohr's theory to higher atomic number and stuff like that. So there are other theories which were developed after Bohr, but that is into wave, quantum, and other probabilistic mechanics. So we do not deal with that over here in JEE. So what we are going to deal with is more classical approach, I would say, and Bohr's approach towards the atomic structure. So now let's see what is Bohr's model of atom. Now there are some critical assumptions which you must know, because you will see in the previous years these assumptions have been directly or indirectly been asked. So take note of all these assumptions. Hello Priyanka, welcome back. Is there cold, Ravindran? No, it's not so cold, but it's not so hot either. So I need a blanket before I sleep. Okay, so let's note down all these assumptions for Bohr's atomic model. The first one is obviously, hello Tornado, welcome. Hello Kamakshi, hello Sneha Pradeep. So we have started with atomic structure and we are going to continue to X-rays. So stay tuned guys, and all those new minions, all those new members, all those new V enthusiasts, do not forget to hit the subscribe button and like the video, because that's the fees for attending today's class. So the first assumption is the electron revolves around the nucleus in circular orbits. Now if it is revolving in circular orbits, there must be something which provides the centripetal acceleration. Just like when the earth goes around the sun or the moon goes around the earth, who provides the centripetal acceleration? The gravitational force. So here, when it goes around the circular orbit, the electron gets pulled by the positively charged nucleus by electrostatic force, and that provides the necessary centripetal acceleration. So now this orbit of this electron around the nucleus can only take some special values, and these orbits are called as stationary orbits. That's the next important point. Hi Neeraj, welcome. So these are special orbits. So understand, an electron cannot go in any random orbit. These are supposed to be such orbits where the energy neither will decrease nor will increase. That's why it's called stationary orbits, because it's so said that when a charged particle accelerates, then it radiates energy. So if electron is an accelerated particle, it should radiate energy and eventually fall inside the nucleus within no time. But that really doesn't happen, and that only happens in stationary orbits where the electron does not release any energy and neither accumulates any energy over a time, and that's why it stays stable in that particular fixed set of orbits. So that's how it is. So now the next thing that you need to understand is the energy of an atom has a defined value in a stationary orbit. So quantum number, think of it Randy like this. It's like coordinates. Just like you have x, y, z coordinates for locating a particle. Similarly, in the microscopic world, to know the situation, the state, or the what a particular object is doing, there is something called as a quantum number. So there are different states. There is something like principal quantum number and so many things which decide what exactly and where exactly it is. Think of it that way. Okay, so the energy of an atom has a definite value in a given stationary orbit. If it jumps from higher to lower orbit, then the difference of energy between those two orbits, E2 minus E1, corresponding to that, a wavelength of light is emitted given by the Einstein-Planck equation. E2 minus E1 is equal to hc by lambda. This is not supposed to be k, this is supposed to be lambda. Okay, cool. Now, the thing is, remember, when you go from one energy to another energy, if one energy is higher, another energy is lower, so high to low energy, the difference will be converted into a photon. What is the energy of a photon? hc by lambda, or hf, or h nu, whatever you want to call it. This is how it looks like. Look at that. There is some light which falls onto it. This is an electron. This is a nucleus. Okay. If light falls onto an orbit, right, that electron accepts that photon and it jumps into a higher orbit. I hope you can see that. The electron jumps into a higher orbit and then it is said to be in excited state. Now once it is excited, it can't stay excited forever. It has to come back to reality, and that's what happens. So the electron jumps back to reality. So change in the energy is accompanied by a release of photon. I hope this makes sense. Similarly, understand that if another photon comes, and if let's say that electron happens to jump somewhere here, then that electron can jump in many sequences, and in that process it can emit even more photons. So this is how it works. If it absorbs the photon of a particular frequency, particular energy, it will make that jump, and when it comes back, it will release those photons. I hope that is clear. So photons are the particle behavior of light, Randy, and I made a special lecture on that previously, yesterday, 10 o'clock. So go check out the past videos. I have explained every property of photon out there. Okay, cool. Now the last important point about Bohr's model is this one, and that is, hello Kathir, welcome. In these orbits, the total angular momentum of the electron around that nucleus is always an integral multiple. That integer is called principal quantum number of h by 2 pi, where h is the Planck's constant. This is very important, correct? So this is very, very important. So the angular momentum of an electron is n times of h by 2 pi. Keep this in mind. And one last thing before we proceed, keep this also in mind, guys. All right. So if you have this as the nucleus, and let's say for example this is some orbit, then the de Broglie wavelength, okay, of an electron, okay, if this is the de Broglie wavelength, okay, the de Broglie wavelength will exactly fit into the orbit. And if I tell you that, for example, this is the radius, then the circumference which is there, 2 pi r, all right, the circumference which is there will always fit n times of those de Broglie wavelengths. Keep this in mind. Yes, this is how it works, and you should remember this. Hello Kathir, welcome to this channel. We Enthuse, welcome all the new members out here. So this is something which you should keep in mind. Next up, radius, speed and energy formulas. Very, very important formulas. Keep this in mind. The radius of the orbit of any electron, okay? So if this is the radius, if this is the velocity, then the radius of any orbit, keep this in mind, is always some constant times n square by z. What is n? N is that principal quantum number. If it's k shell, it is 1. If it is L shell, it is 2. If it is m shell, the third one, it is 3. What is z? The atomic number. It is the atomic number. So that's one thing, and this is the principal quantum number. Okay, principal quantum number. Okay, great. So it's some constant into n square by z. Keep this in mind, very important formula. Next up, don't have to remember what that constant is, that's okay. Next up, velocities formula. Keep this in mind, the velocity of the electron which is going around, that is again some another constant, so constant 2, okay, into z divided by n. That's another thing which you should remember. All right, okay, so keep this in mind. And last thing, the total energy, which is the sum of kinetic energy plus the potential energy of that electron. The kinetic energy because of its motion and the potential energy, that energy which is there is going to be minus 13.6. Now this is something which you should remember, the constant, all right, z square divided by n square. So this is again a very important formula. The total energy of an electron is minus 13.6 z square by n square, but keep this in mind, this is in electron volt. Yes, this is in electron volt. That's how you should remember it. Hello Roshan, welcome. Yes, keep this in mind. So Randy, concentrate on the session now, Randy, all right? So focus on the session. You can do everything else later on. First focus, and you can always comment and you can chat with each other by the end of the session. Hello Pranaya, Mola, welcome to this session of X-rays and atomic structure. So note down all these formulas. I hope all the V enthusiasts are already making notes of all these things. Very, very important. Now, the next thing is, how do these energies look like if I plot it in a graph? Yes, so E stands for energy, the total energy, mechanical energy, which is potential plus kinetic is the energy. Now, for an hydrogen atom like structure, this is the nucleus, this is the K shell, this is the L shell, this is the M shell, this is the N shell, and so on and so forth. I just told you about the energy, guys, and if you can substitute the values, so energy in the nth orbit will be minus 13.6 Z square by N square. So if you take for hydrogen, all right, for hydrogen atom, what will happen? Z will be equal to 1. So for hydrogen atom, Z will be equal to 1. So the first orbit, that is N is equal to 1, 1 by 1 is 1, so it will be minus 13.6 electron volt. So the first orbit, N is equal to 1, will be at minus 13.6. The next orbit, when N is equal to 2, so 13.6 divided by 2 is going to give you 3.39, but a negative value. So it's going to be less negative. Keep this in mind. So that's how it works. The next orbit, put N is equal to 3. So 3 square is 9. 13.6 divided by 9 is 1.51, but with a negative sign. Now you can see that this gap is much more than this gap, because obviously 13.6 to 3 is almost 10.2. From here to here is not so much. The next gap will be even smaller for the energy difference. The next gap is going to be even smaller. So remember one thing, from first to second the energy difference is too much. From second to third the energy difference is smaller, and from third to fourth it's even smaller. Keep this in mind. Yes, is that clear? Is that clear? Yes. Yeah, very important formula, and more important is to remember that the energy levels are, negative, number one. The zero energy is when? What does this zero energy stand for? This stands for it is out of the atom. It is out of the atom. That means, think about it, it has been ionized. It has been ionized. That electron has escaped that atom. It has got zero energy. It's free. It's no longer bonded to that atom. That's what it is. That is when N is infinity, and it's gone out. That's N is infinity. That's when it is zero. So this is something which you should remember. Alrighty, let's get going with the next. Yes, the free guy. Very good, Pranayam Orla. Very good. Now, remember these processes. Don't look at this diagram for now. Look at this beautiful little electron out here. I hope you can see that. This is a beautiful living electron. There is a small photon, a wavelength of light which is coming, and it hits, and it hits that atom. So that electron absorbs that photon, and that electron gets excited. So if a particular photon of certain energy, whose energy is exactly equal to the energy difference, please understand this. If the photon's energy is not equal to the energy difference, then it will not jump, it will not absorb. Only if the photon's energy is exactly equal to energy difference will it jump, and this will be then said to be in the excited state. Once it is excited, it will again come back to the ground state. You can see in the next diagram. So once it is excited, it will come back into the ground state, and it will release that photon. You can see there is a release of photon out there. It's very faint, but that's how it is. All right. I hope this is clear. Is that understood? So each transition has been named depending on who discovered it. Welcome, Asmi. And depending on that, they have been named as Lyman, Balmer, Paschen, and bracket series. So what is Lyman series? Lyman is basically whenever the electron gets de-excited and comes to the ground state from anything to n is equal to 1. So anything to n is equal to 1 is Lyman series. This is the first wavelength, second wavelength, third, fourth, fifth, and so on and so forth. Balmer is when it comes from anything else to n is equal to 2. Paschen is when it comes from anything else above it to n is equal to 3. And bracket is when it comes from anything else above it to n is equal to 4. Keep this in mind. Very, very important diagram. Yes. Yeah. So remember this. Oh, Kirito, you need to remember this chart. Hello, Anvisha. Welcome to this session. Now, what is more important is for you guys to also remember the formula. Yes, that's important. Also, I hope you have taken note that these gaps are not constant. In fact, they are reducing. You can see that they are reducing. Remember, these lines have been drawn in accordance to energy. This has the lowest energy. This has more energy, more energy, more like that. That's how it works. And Vijay, you are a little bit late, but it's okay. You can just rewind back the session a little bit, catch up at 2x speed, and you can come live. All right. Okay. So remember, the energy difference between those any two levels is going to be HF. It's going to be HF. So this is the energy difference between the orbits, and this F is the frequency of the photon which would be emitted, and then solving that you get the wavelength of that photon, and that wavelength of the photon comes out to be R into Z square into 1 by N1 square minus 1 by N2 square. Now what is this formula going to give us? Let me tell you. See guys, this lambda, alright, this lambda tells you the wavelength. Alright, it is going to give you the wavelength of the photon. It's going to give you the wavelength of the photon. So whenever an electron makes a jump, remember light will come out. So it's going to give us the wavelength of that photon. What is R? R is a constant. I'll come to that. Z, you know, is the atomic number. N1 and N2, those are, the orbits from where it has made the transition. It has come from here to here. You put n is equal to 6 and n is equal to 3. So those are the two values of n that you're going to put. That's how it is. Hi Nitish, welcome, welcome. Yes. And this value of R, which is called as Rydberg's constant, is 1.09, all right, into 10 to the power 7. This is something which you should remember. This is something which you should remember. Yes, 1.09 actually 7, 1.097 into 10 to the power 7 SI units. That's how you should remember. Now, hello Sainandan, hello Ronak, welcome. Is N2 more than N1? So don't have to remember is N2 more than N1 or N1 more than N2. Just think this way. You have to keep this number, this 1 by N1 square, bigger than this number. So if I tell you it makes the transition from, let's say, 5 to 2, obviously what I will do to keep this number bigger, I will keep this N1 as 2 and N2 as 5. That's all you need to keep in mind. So always keep it bigger minus smaller. Yes, Ronak, it's a chemistry topic, but it is there in math, modern physics. I hope you know that in 12th standard. Yes, so you need to know this. Cool. So before we go to problems and X-rays, for all those students, let me make a small announcement. Hello Vaishnavi, welcome. For all those students who are, facing difficulties in any of these, like probably you have a lot of problems and you have no one to solve them, or you want to ask some doubts but you don't know where to ask and you want to get instantaneous responses. And some of you probably have very few weeks or days left and you want to revise the entire syllabus in the next few days in a very planned, systematic and such a manner which will optimize your marks. And also it's very important that probably you have a lot of things going on. Maybe you have your school's exams, maybe you have your JEE, and maybe you have a lot of backlogs. So you need to also manage your time. You need to schedule. How do you do that? Is there somebody who can guide me? Acha, do this for this week, do this for that week. So what about that? So if you want to do all of this and you want to crack your board examinations, we have made a special plan for all of you out here. And I would love to you to hear this out, because what we have planned is some really amazing test series. In fact, 20 tests every Sunday, and this test will test different kinds of concepts from different parts of the syllabus. So there are part tests as well as full syllabus tests. And best part is there is going to be discussion after every test, live discussion. That's very important. Also, what we have planned is, there will be a dedicated person, or in fact many people, who will be solving all your doubts from morning till night. Yes, from morning till night, not just after the class, but even inside the class. And we have planned so many sessions to cover the entire syllabus of 11th and 12th from amazing best master teachers whom I personally know, and I would definitely recommend you guys to learn from them. And they will not only teach you all the 11th and 12th topics, but also guide you in a very systematic, disciplined manner all the contents along with the application of concepts in these problems. All of this in a crash course, the link of which is there in the description box below. Now the usual price of the crash course is 10,000 rupees. And the usual discount which you get on any channel is 20%. But because of Valentine's Day and love is in the air, so we are going to give you whooping 30% discount. Yes, and the price comes down to just 7,000 rupees for all of this, and there is much more which has not been put up on the slides. So many other things that you are going to get. So guys, if you are a 12th or a dropper students, I would highly recommend you to check out the description box below and open the link, check the details, join the course because it is going to start on Monday. So the batch is going to start on Monday. So do not miss this because this 30% offer is only going to be there for a few hours or maybe a day or two max. So I'm not sure if this deal is going to be there tomorrow. So go ahead, use the coupon code SHCC and get the best out of it. All right, cool. So let's start with some questions, and there it comes. There it comes. So 2020. All right, no problem, Roknak. I know you are in 11th, so maybe. So there's a long time for you to actually come to this topic, but no harm in learning this topic. So you will be definitely a chapter ahead as compared to your other peers and other colleagues in your institute. Okay, so the time period of revolution of an electron in its ground state in hydrogen atom is so and so seconds. The frequency of revolution of the electron in its first excited state is how much? Kirito, you should have had your dinner. Thank you, Greats Gokul. Thank you so much. I'm there for all of you. All right. So let's see how do we do this. Cool. Let's do this. I will hide the options. It's no longer needed. In case you have noted it down, well and good. So what do? We have to find the frequency of revolution of that particular electron. So what I'm going to do, what is the frequency? So there is the nucleus and that electron is going to rotate around. So what is the frequency of revolution? It is 1 by time period. Now what is time period? Time period is distance, which is circumference. All right. Time is distance by speed with which it moves. Now do not forget the circumference is actually nothing but, I can just write it down over here only maybe. So the circumference is nothing but 2 pi r and speed is nothing but v. Now I hope you remember, I just told some time back, what is r proportional to? Radius of the orbit is proportional to n square by z. So it will be n square by z into some constant, let's say constant 1. Isn't that right? And what is velocity of that electron proportional to? It is proportional to z by n. So z by n into some constant. This is a constant, this is a constant, this is also a constant. So won't it become a new constant? And that will become z square by n cube. So frequency is inversely proportional to n cube. That's what I got from here. Now starts the actual problem. So that is why I told you it is very important for you to remember who is proportional to whom. And only if you remember that you can arrive to this conclusion. Now once I get this, I know the atom is the same. So Z is something which I'm not going to touch. I'm going to say F2 by F1 will be, think about it, N1 by N2 whole cube. Inverse. It is inversely proportional to the cube of N. Yes. So yeah, that's how it is. That's how it is. Sai Nandan, I have in fact, we have made special videos how to score more than 99 percentile on this channel. So please watch the previous videos. All right. So Randy, I think you need to watch the waves wala video. I have made it. So just check the playlist and the past videos. What is a wavelength? Like the distance between crest and crest or trough and trough. So you need to see it from the basics out there. Okay. So F2 by F1. All right. So I'll just take F1 over there. And what is N1 by N2? Let's think about it. It was earlier in its ground state. That means n was equal to 1. And then the electron is in its first excited state. First excited means it is 2, n is equal to 2. So basically it is 1 divided by 2 whole cube. And do not forget, the first frequency is not given, the time period is given. Yes, the time period is given, like you can see over here. So what is frequency? 1 divided by time period. And what is the time period? 1.6 into 10 to the power minus 16. That's what is given to us. And 1 by 2 cube is nothing but 1 by 8. Now you just need to solve this, and that's going to give you the frequency. I hope this makes sense now. Cool. So that is going to give you the answer, guys. So just check it out. If it is going to be approximately 7.81 something, all right, into 10 to the power maybe 14 or something like that hertz. Yes, probably that should give you the answer. Okay, is that clear? So what all concepts are used? First, you need to know you need to know that this is ground state, means this quantum number. First excited means this quantum number. Then you need to know the formula for velocity. You need to know the formula for radius. And from that, also use the knowledge of circular motion. Yes, because circular motion is also used over here. And then establish a relationship, and the rest is mathematics. Okay. Can we use spectrum or Rydberg equation, Harsha says? Well, Harsha, no. I'll tell you why. Because that equation is used when the electron transits from one orbit to other orbit. Please understand, this frequency is not the frequency of the wavelength or that wave which is emitted. This is the frequency of the electron which is actually orbiting. So that is why you cannot use this equation, that Rydberg equation. I hope that is clear, Harsha. A very good doubt actually. Okay. I hope, Randy, you will watch the previous videos to understand what waves is, because I have started from the basics what a wave is. And if you are in 11th, I'm guessing you are in 11th, don't worry, we'll come to that in detail again. I'll be starting the 12th standard batch very soon in March or April or something like that. Okay, so that's the answer, 7.8 into 10 to the power 14. Let's get going to the next question, 2020 question. These are asked in previous years. Like you can see, this year number is mentioned just so that you know when was it asked in JEE or mains or advanced or whatever. And the first member of Balmer series of hydrogen atom has a wavelength of these many angstroms. The wavelength of the next member, the second member in the Balmer series in nanometers is how much? That's what the question says. So let's see how do we do this. Now, let me bring back that diagram, which is important. So, Lyman-Balmer. So, Balmer means, n is equal to 2. Now, the first member, all right, let's see. This is n is equal to 3. This is n is equal to 4. So, the first member means the transition from here to here. And the next member means the transition from here to here. So, this is your Balmer series. Okay, now let's do this using this formula. 1 by lambda 1. Lambda 1 is 6561 is equal to Rydberg's constant or some constant, really doesn't matter, RZ square, into 1 by, there will be a smaller number here, remember smaller number, and minus 1 by that bigger number here, because you want to make this positive. Smaller number amongst 2 and 3 is obviously 2, so it will be 2 square, and 1 by, you will have obviously 3 square out here. I hope this makes sense. Okay, so guys, next is just do the simple math. Okay, so 3 square is 9, 2 square is 4, so it will become 9 minus 4. After taking LCM, this will become 9 into 4. So this will become into that constant, obviously, into that constant. So you will have that constant multiplied by 9 minus 4 is 5 and divided by 36. That's what you're going to get. Check this out, constant into 5 divided by 36. That is for the first member. Now for the second member, you will use the similar formula. 1 divided by the new wavelength is the constant, but this time it will be from 4, n is equal to 4. So instead of 3, you put 4. So you're going to get 4 square is 16 and 2 square is 4, so LCM is 16 only. So 16 minus 1 divided by 16 into that constant. So that is going to give me constant multiplied by, all right, 15 by 16. Just check this out. Just check this out. Is this what I'm going to get? Oh, wait a minute. It should not be 16 minus 1. Just hold on. So this is 4 and this is 16. So 4 4s are. So 4 minus 1, my bad. So 4 minus 1 constant. So this is going to give me 3 times the constant by 16. I hope this makes sense now. Okay, cool. Now, if this much is clear, just divide both of them and you will get the answer, guys. So 1 by 6561 divided by 1 by lambda is equal to constant will cancel. I hope you can see 5 divided by 36 and 3 divided by 16. So lambda will go on the top and 6561 will come there. So 6561, okay, multiplied by 5 multiplied by 16 divided by 36 multiplied by 3. Now this answer is what will give you the wavelength. All right, so it is going to give you 4860 Angstrom. That's what it's going to give you. All right, so which is 486 nanometer. Yes, Sarvesh, I do know, but this is an English channel, so I'll have to keep it in English. All right, is that clear? Everyone understood how to solve this? It's pure use of formulas and rest is division, ratio, proportion. That's it. Or kuch nahi hai. Okay, so you should know what is Balmer series. That's why I told you, remember that diagram. Correct, Sai Nandan, that's 486 nanometers. Okay, let's get going to the next question. How about this? Let's see. The transition from the state n is equal to 4 to n is equal to 3 in a hydrogen-like atom results in ultraviolet radiation. Infrared will be obtained from which to which transition? Let's see. How can we do this? Okay. So guys, again, we need to go back to our diagram. Remember, n is equal to 1, then n is equal to 2, then n is equal to 3, then n is equal to 4, then n is equal to 5, and so on and so forth. Now, it is clearly mentioned that from 4 to 3, okay, it results in ultraviolet. So from 4 to 3, that means this one. Okay, this results in ultraviolet radiation. Now think about it. Infrared will be for which to which? Now if I have to do a comparison, guys, who has more wavelength, infrared or ultraviolet? Wavelength of ultraviolet or wavelength of infrared? Now this is something you should know. I had given you the electromagnetic spectrum. In case you have forgotten also, don't worry. Red has more wavelength than violet. Keep this in mind. Because red is used to signal danger, and so if you want to signal danger, you want it to reach farther distances. Think of it that way. So red has larger wavelength and that's why it is used to signal danger. So red has larger wavelength, so infrared has more wavelength than ultraviolet. So who has more energy? The energy of UV is going to be more than the energy of infrared because energy is hc by lambda. More lambda, less E. So now think about it. Here, if infrared is going to have less energy, so which transition will give you lesser energy than ultraviolet over here from 4 to 3? Will 2 to 1 give you less energy? No, this is huge difference. 3 to 2, that's also huge difference. 4 to 2, that's also huge. 5 to 4, now that is interesting, guys. 5 to 4 is a very small energy, and that's what we want. The energy should be small. So hence, this will be infrared. I hope that's clear. Yes, very good, very good, very good, very good. I hope this is clear. Excellent. No, UV does not necessarily mean transition to 1. Sainandan, we have to just assume that whatever they have given is correct. Just think of it like that. Just assume, maybe it's not a hydrogen atom, maybe it's something else. We don't know whether it's hydrogen. Okay, it just said it is a hydrogen-like atom. It's not exactly hydrogen atom. So it might be for some other transitions as well. So that is how it is. Okay, so 5-4, correcto. Sarvesh, my hometown is Pune. Amchi Pune. All right, cool. Let's now go to the best problem of today. So Tornado, this session will probably get over by 11:15. Okay, so this is like a midnight session. Are you guys ready to solve one of the most difficult questions which was asked in 2015? Are you guys now ready? Let me know. Yes, let's do this question now. This is very interesting. Don't worry about the options. Don't even bother. If one were to apply Bohr's model, what was I telling you? Bohr's model questions do come in the exam. So you need to remember all the postulates, the theory of Bohr's model. On a mass which is having some charge moving in a plane under the influence of a magnetic field, the energy of the charged particle at the nth level will be. Now there are so many chapters combined in this, let me tell you. Yes, magnetism, circular motion, and energy, and then modern physics, of course. So many chapters are combined, and that's what you're going to see. Yes. Now, remember that if a charged particle goes in an orbit like this is a charge mass m, and that is because it is under the influence of a magnetic field. You should remember or recollect that formula, like the circular motion which is going to be conducted mv square by r is because of the magnetic field's force, which is qvb. qv cross b gives you that magnetic force, which is mv square by r for that circular motion, and hence you are going to get r is equal to mv divided by qb. That's one thing that you will get. And also do not forget, you also get the time period, and you can get that very easily. The time period is nothing but 2 pi, all right, 2 pi m by qb. You can get this very easily by dividing distance by speed. So dividing distance by speed, you will get it. Yes, very important. Now, well, Randy, it is totally worth. It's not called wasting, it's called enjoying. Some people call it wasting. I don't know why some people, I know some people have even made videos saying that, is it worth wasting 2 years or is it worth wasting 1 year of rigorous studies to crack JEE? I don't really think, if you coin the word or use the word wasting, then definitely it is wasting. But if you coin it properly, I feel it is enjoyment. I feel you should enjoy these problems, and only then you can crack the JEE exam. If you think I'm going to waste my 2 years, only then I can crack the JEE exam and hence I can get a better life, then for sure you will waste it. But if you think I'm going to enjoy this subject and I'm going to learn all the concepts and let's see what's there ahead, I want to go to IIT because I want to make intelligent friends, I want to have a good crowd, I want that freedom, I want that head start, then for sure you will crack it. Yes, cool. So let's get going ahead, and here it comes. So time period is 2 pi m by qb. I'll need that. Now, what will be the total energy of the particle? It will be kinetic plus potential. Is it that right? Kinetic plus potential. Now, what is the kinetic energy of the particle? It is half mv square. What is the potential energy of the particle? Now, do you remember, if there is a magnet, all right, placed in magnetic field, it has potential energy m dot b. I hope you remember mb cos 0, mb cos theta, etc. Similarly, this is also a magnet, a charged particle. How? Because a charged particle moving around in a circular path is like a current carrying wire. It's a current carrying loop. So current carrying loop is like a magnet. I hope you realize that. And the moment you realize it, you will understand the potential energy is mb. Yes, it is mb. And what is the value of m? The value of m is current into area. The current into area into b. That's what it is. I hope this makes sense. Now it's going to be a very tricky problem. I'm warning you in advance. It's not so simple. That's why I said it is one of the most difficult problems combining so many chapters. Now this is going to be equal to half m. Well, what is v square? Can I get V square from here? Yes, I think so. I can rearrange this term and I can get V square. So V square will be RQB divided by, all right, RQB divided by M whole square. Okay. Plus, what is the current? If a charge flows, all right, once in a time period, the current will be the charge which has flown upon the time period, all right, and what is the area? It is pi r square, all right, into B. Now, the next step will be, all right, so M and one of the M will get cancelled, so you'll have r square, q square, B square by 2M plus, look at this, this T can be substituted from here. Yes, it's going to be one crazy looking formula. So Q divided by, time period is 2 pi M. So 2 pi M and QB goes on the top. All right, QB goes on the top and into pi R square into B. Great, let's see what happens. This will become R square, Q square, B square by 2M. And this is also pi goes R square, Q square, B square by 2M. Yes, it is the same thing. R square, Q square, B square by 2M. So this is just going to be half plus half is 1. So it's going to be R square, Q square, B square by just M. That's what I got. Now I no longer need this, I believe. I no longer need this. But I have not yet solved the problem completely. There's only one thing remaining. Using Bohr's model, L is NH divided by 2 pi. And what is L? L is mvr, all right, and that is equal to NH by 2 pi. Okay, so what else? Okay, so M, and I hope you remember from the previous result, R was mv by qb. R was mv by qb. So therefore V was RQB divided by M from magnetism, right? So put this value of velocity here. Yes, put this value of velocity here. So you're going to get R and what else? RQB divided by M, and this R of course is equal to NH by 2 pi. So this was R. Now mm goes, okay, cool. So this will become R square QB, mm has gone, is equal to NH by 2 pi. Therefore R square is equal to NH by 2 pi, and that QB also comes over here. So this is what happens. You'll get this value over here. Why did I do that? Because I want to get rid of R square. Yes, you can see that. I can get rid of R square from there. Now substitute that back. So I'm just going to erase all of this. I don't need it. So guys, the final energy will be, instead of R square, put this value. So you will have NH by 2 pi QB into this remaining terms, Q square, B square divided by M. So that is going to give me NH. One of the Q's goes away, one of the B's goes away upon, yeah. So I guess this should give me 2 pi and M. That's it. Check this out. Check this out. Yes, check this out. I hope this is clear. I hope this is clear. Yes. Okay, just check this out. Yes, so that's how you need to do this, guys, and that's how you get the answer. I hope this is clear, guys. Okay, yeah, lot of combined things out there. Okay, so my point was that you don't have to worry about, how to solve it. The thing is, if you remember the formulas, you'll just keep solving it, and that's about it. Yes, is this an advanced problem? Yes, it's an advanced problem. But I wanted to do it just because I wanted to show you how chapters can be related. Now let's move on to X-rays, shall we? Let's move to, yeah, let's move to X-rays. I hope that's fine. Cool. Yeah, a lot of people have gained some gray cells out there. Very good, very good, very good. Chalo, let's get moving then. Let's get moving. Cool. So, what are X-rays? Now, some properties of X-rays that I'm going to give you now. Before that, here is a simple question. What is the wavelength? Harsha, next week is going to be mainly questions because the concepts are almost done. So it's going to be mainly questions. Okay. So what is the wavelength of X-rays approximately? Come on guys, how many of you can give the answers? Just check this out. What is the wavelength of X-rays, guys? Come on, come on. What is the wavelength of X-rays? Anybody? No? Okay. D? Well, that's correct. In fact, I'm going to tell you all the properties of X-rays, and here it comes. Note it down. X-rays was discovered by Röntgen. Keep this in mind. Who has discovered X-rays? Röntgen. Keep this in mind. They are very short wavelengths of the order of Armstrong. Yes, the wavelength of X-rays is typically of some Armstrongs or lesser than Armstrong. Keep this in mind. Next important property, they penetrate and they are invisible to naked eye. And they penetrate through almost everything that is there around us, including human flesh. Yes, including human flesh. They are highly penetrating because they have very short wavelength, and that's why they have very high energy. And because it's nothing but light, so light is neutral, it's neither positive nor negative. Remember, they are photons, so it is electrically neutral. That means it will not get deflected by electric field or magnetic field. Keep this in mind. And because it is at the end of the day an electromagnetic wave, so all electromagnetic waves in vacuum travel at the speed of light, which is 3 into 10 to the power 8 meters per second. Next important stuff, because they are highly penetrating and because they are highly energetic, they can also knock out the electrons of the air molecules. And because they can knock out the electrons of air molecules, that means they will ionize the gas through which they will pass. So Himal, why they cannot penetrate through bones? Similar reason why light can travel through glass and why it can't travel through wood or stone. So similarly, some wavelengths can travel through some medium, they cannot travel through some other medium, maybe because that medium does not permit it for some weird reason. Alright, so some objects are opaque, some are transparent. Similarly, understand it can cause fluorescence for certain crystals. So if X-rays are incident on certain crystals, it can emit more light, and that is called as fluorescence. And very important property, it cannot be focused using lens because they cannot refract themselves. Yes, through glass they do not get refracted so easily, so the light will not bend or the X-rays won't bend through glass. So that's why using a lens you will not be able to focus the X-rays at a particular point. Yes, correct. Bone is opaque for X-rays, correct too. And if you have a photographic film and you place it in the path of X-rays, it will expose it and it will get washed out just like normal light does. So photographic plates do affect or are affected by X-rays. Keep this in mind. And very important, it produces chemical and biological changes in the body. So a lot of exposure to X-rays is actually not considered to be good because it can definitely damage your skin and other tissues in your body. So very, very important properties out there. Hello Manoj, welcome. And yes, another important thing, it produces secondary and it produces some kind of scattered radiation. So this is used to identify crystal lattice structure in atoms and other materials. So it can be scattered and just like other electromagnetic waves. So the answer for the previous one was 10 to the power minus 10 meters. Yes, correct. So Kirito, for focusing them, you will need very special material so that it can change its path. Yeah, correct. Okay, so that's how it is. Yes, hello Anthony. Yes, welcome. Okay, chalo. Let's get going to the next question. Let's see how many of you can do this actually. The energy of an X-ray photon is 4 kilo electron volt. Its frequency is nearly how much? Come on, think about it. How much energy of an X-ray photon will be there for the energy of 4 keV? Come on, think about it. Let's see. So we're going to see that, Arjun, don't worry. All right. So, well, it's very simple how to solve this. See, the energy is given. And what is the energy of any electromagnetic wave? The energy of any electromagnetic wave, photon, is given by hc by lambda. Isn't that right? Or I can just write it as hf. Energy is nothing but hf. Alright, and the energy is given 4 kilo, matlab 10 to the power 3 electron volt, that is 1.6 into 10 to the power minus 19 is equal to h is 6.6 into 10 to the power minus 34 into f. So the only unknown over here is f. Solve this and that should give you the answer. Check it out. Yes, check it out. What is the answer? Check it out. Yes, is it 10 to the power 18 or 10 to the power 17? I think it should come very close to some 10 to the power 18 hertz. Just check it out if it is coming out to be 10 to the power 18 hertz. And very interesting thing. Look at this chart, guys. Very important chart. I have given this kind of a chart in electromagnetic waves as well. This side has shorter wavelength, more energy, more frequency. This side has longer wavelength and less frequency. This is a small region which is visible. This side longer wavelength, infrared. After red you get infrared. Beyond blue or violet you get ultraviolet, and beyond ultraviolet you get X-rays, and beyond X-rays you get gamma rays. That's how it is. Correct. So remember this, very important. Okay, cool. Let's get going to the next one. So 10 to the power 18 hertz lies somewhere over here. 10 to the power 18 hertz, very high frequency. Okay, so how do you produce X-rays? Let's have a look at it. And see what is so special about the production of X-rays, and because that is going to be one of the major theory points from which questions are asked in JEE Mains as well as advanced. So let's do this. Now, the basic setup for producing X-rays is called as a Coolidge tube. So it is called as a Coolidge tube. Now, in this Coolidge tube, what happens is there is a hot filament through which current passes. And when current passes through that hot filament, the electrons can easily get knocked out and they can be easily taken away from that hot filament. And to take it out from that hot filament, what is done? So this filament carries current, so there are a lot of free electrons. You apply a voltage difference between this end and this end. So you create a strong voltage difference. If there is a big voltage difference, what will happen? There will be a very strong electric field. So between two ends, if there is a strong voltage difference, you will also have a very strong electric field. And the moment the electric field is very strong, it can easily apply a strong force on that electron and easily pull out that electron from that filament. Isn't that right? Yes. So think about it. If that electron gets pulled out and in that electric field, what will happen? These electrons will accelerate. Yes, it will accelerate between those two ends between which there is some potential difference. Now these highly energetic electrons are going to hit this side. Yes, and this is called as the target material. What is it called? Yes, it is called as the target material. This is very important. Those electrons will hit that target. That target will also have its own electrons, orbits and all that. And in that process, when these electrons hit those other electrons in that target, those electrons will fly, these electrons will lose energy, and a lot of things are going to happen over there. Yes, it's going to be like a doom daram dish dish talk, and you will see from that you are going to see electromagnetic waves, and those electromagnetic waves are going to be in the X-ray region if this potential difference is high and if this target material is suitably chosen. If the voltage difference is high and the target material is suitably chosen, only then you will see X-rays will come out of this dim dush tak. Yes. Okay, Shreyas, I got it. Don't worry, I'll check it out. Okay, so I hope this is clear. Everyone understood? Oh my God, Pearl, you had an earthquake. My God, crazy. I hope you guys are safe and please stay under the table if the earthquake persists. Okay, so this is exactly what happens. This is the cathode, this is the anode. Look at that. There is a strong potential difference, very strong potential difference. correcto, and you will see that will accelerate those electrons. They hit that anode, which is the target material, and over there a lot of explosions, or you can say a lot of heat is produced. So actually you need to continuously cool it using a coolant, and then photons are ejected, and those photons are X-rays. Is this working principle clear? All the minions, all the V enthusiasts, is it clear? Is it clear? Everyone? Yes, that's very important. Correcto. Let's get going. So in this Coolidge tube, if this much is clear, okay, keep this in mind. The electrons are accelerated by potential difference, I will say V, and that gets converted into kinetic energy of electrons, and that in turn might go to heat loss plus the energy of photons in the X-rays. Very, very important equation which I am giving it to you right now. Electrons which are accelerated by the potential difference will gain some energy, and that is kinetic energy, and that kinetic energy will convert into heat plus energy of the photons out there. Yes, very good. Cool. So now going ahead, are these X-rays which are produced of a particular wavelength, a single unique wavelength? The answer for that is no. It is not of one particular wavelength, and let's see why. In fact, there are two kinds of wavelengths which are produced, and they are categorized into two separate categories. You will see that, and one is called as the continuous X-rays, and the second one is called as characteristic X-rays, because you will see the wavelengths of the X-rays which come out of this Coolidge tube are not of one wavelength. They are of many wavelengths, and those wavelengths also differ if you plot it on a graph, and you'll see that now. Hold on. First, let me talk about continuous X-rays. Just now think about an electron, all right, this electron which was accelerated, highly energetic, and it enters that atom, but it does not knock out any electrons because they are very fast. They miss. It's just like how they show in movies, like the hero is driving a car and he misses all the traffic, and this electron comes out but with a lower energy. So the obvious question is, if the electron lost some energy, where did it go? Obviously a photon would have been emitted. I hope that makes sense. Now this electron which has lower energy might enter some other atom, alright, some other atom, and maybe as it exits out of that atom, it will it will leave out another wavelength, and that has come because of the loss of energy. So this electron which continuously loses out energy will keep on emitting photons due to loss of energy. Keep this in mind. All right, continuously emits photons because of loss of energy. Now I hope this makes sense that there are two possibilities in this. See, the electron had lot of energy. It lost some energy, again lost some energy, again lost some energy, again lost some energy, again lost some energy, and eventually it became zero. That's one possibility. Another possibility, that electron which had lot of energy loses some energy within 2-3 steps and dies out. That's it, no energy. Another possibility, the other extreme, the electron which has lot of energy loses everything in one go and dies out. That's it. Now in this process only one photon will be emitted. Think about it, only one photon will be emitted. In this process many photons will be emitted, but their energy will be less. I hope you understand that. Their energy will be less. In this case the energy will be in fact the highest. I hope that makes sense. And that one which has the lowest energy, remember, will obviously have the maximum, alright, it will have the maximum wavelength, correct? and the one which has the highest energy will obviously emit the minimum wavelength. I hope this is clear. This will have the lowest wavelength. Is that now understood? Yes, several photons but less energy or more wavelength, and the one which dies out immediately will emit maximum energy or the smallest wavelength. Now this is very important, that what will be this maximum and minimum value? Very important question. This has come in JEE Mains Advanced NEET so many times. So what will be the maximum wavelength, guys? Any answers to this? Any answers to this? What will be the maximum wavelength? Think about it. How many steps can it take to die out to zero? Infinite, right? It can lose 0.01 energy, 0.001 energy, 0.001 energy. So if it can lose energy in many steps, the energy which will come out will be very small. If the energy is very small, the wavelength will be very large. Correcto? No, it's not going to be in infrared, don't worry. So it is going to be almost infinity. Yes, the wavelength is going to be infinity. Keep this in mind. Very large wavelength, very small energy. Very large wavelength, very small energy. Okay? And then you might be wondering, sir, then what is the minimum wavelength? Is that going to be zero? Nah, it's not going to be zero, because whatever energy it can lose is the energy of the photon. What is the energy of that electron? What is the energy of the electron? Because only that can be converted into energy of that photon. Think about it. The energy of the electron only can be converted into that energy of photon. So what is the energy of the photon? hc by lambda minimum. Think about it. And the energy of the electron will be the charge into the voltage difference. Charge into voltage difference. Think about it. Correcto. So that is the lambda minimum. I hope this equation gives you the value of lambda minimum now. Is this now clear? So you can see range of wavelengths from the minimum wavelength to the maximum wavelength which you are going to get. Yes. Correct? Understood? Charge into voltage difference is energy. That energy gets converted into photon, which is hc by lambda. Correcto? And that's why the graph is going to look like this. Excelente, excelente, Arjun, Harishran, greats, Krito, Harsha, Sneha, very good, Plavita, very good, very good. So this is the graph. That is why it is called continuous wavelengths or continuous X-ray. This is intensity versus wavelength. Very large wavelength, very small intensity. Very small wavelength, very less number. But most of them will have certain wavelengths. It will peak somewhere. That's none of your concern, but the graph will look something like this. Excelente. Vanakkam Santosh. Alright. Now, these are not the only X-rays which come out. There is one more type of X-rays which come out. Pay attention, the story is going to get interesting now. That is called as characteristic X-ray. Remember, one electron which enters that atom but misses hitting any of those electrons, just loses some energy and emits photons. That used to produce continuous X-rays. But imagine an electron hits, accident happens. The electron hits one of those electrons in those orbits. What will happen, guys? What will happen? It will knock away that electron. Zoop karke. It is going to be so energetic. It's going to throw away that electron. It's like a Volvo bus was coming at 300-400 kilometers per hour. A Volvo bus coming at 300-400 kilometers per hour, and there is a bichara, another Volvo bus going at some 10-20 meters per second or 10-20 kilometers per hour. What will happen in that collision? Zoop, those both Volvo buses will just be thrown away. That's what is going to happen. And you will see emptiness, a void being created here. Now, the moment there is a void which is created, what is going to happen? Is the atom going to like it? It's going to be like, hey, I don't like this. There is a void here. Please fill it up, somebody. Yes, it will create a vacancy and it will be like, hey, what are you bunch of losers doing out here? Come on, jump in out here. Come on, fill in this void. So it's going to ask these electrons to fill in over here. And the moment there is a void here, it's going to ask more electrons to jump in and more electrons, and those electrons which have low energy will be also captured in the due process. So basically you are going to have transition of electrons from high to low orbits. And what happens? Yes, high to low transition, whenever it happens, what happens? Photons are emitted. And are these photons of any random wavelength? No, we have seen that. So there are of particular wavelengths. This to this wavelength. N is equal to 4 to n is equal to 2, this wavelength. N is equal to 7 to n is equal to 1, certain wavelength. So these are going to be characteristic wavelengths because they depend on the target material. So it depends completely on this target material's electron structure, nucleus, everything. Correcto. Is this now understood? Now they have special names. Do you remember Lyman, Balmer, Paschen bracket? Lyman, Balmer, Paschen bracket. That was for hydrogen. But for X-rays, they have a different name. This is the K series. This is the L series. This is the M series. And this is the N series. So, from here to here is called K alpha. From here to here is called K beta. From here to here is called K gamma, and so on and so forth. And if it falls on the L shell, it is L alpha, L beta, L gamma. If it falls on the M shell, M alpha, M beta, M gamma. That's how it is. As simple as that. So very similar. So that means the formulas are also going to be very similar. Correcto. I hope this is clear. Yes, this is how it is. Correct. So if you combine these characteristic wavelengths, remember, characteristic wavelengths will be peculiar. This signature, it will be like the signature of that target. Continuous will be a graph like this. The combined graph is going to look like this. Peak, sudden peaks. So the graphs of intensity versus wavelength will always start like this. Sudden peak, then sudden peak, and then sudden peak, and then sudden peak. These peaks are characteristic, and this continuous ones is over here. So this is continuous plus characteristic superimposed over each other. Excellent. Okay, let's solve some problems. Here it comes. There is a tube which is operated at 40 kilovolts. Find the shortest wavelength of the continuous X-rays. Okay, think about it. What is the shortest wavelength of the continuous X-rays? Just now I gave you the formula. Just use that. Nothing great. Just use that formula. So, what did I just tell you? It is operating at 40 kilovolt. So that means the charge into voltage difference will be Hc by lambda minimum. Use this. Electron charge 1.6 into 10 to the power minus 19. Okay. Voltage difference 40 kilovolt. So 40 into 10 to the power 3. Hc, well, Hc's value you can put 6.6 into 10 to the power minus 34 into C, which is 3 into 10 to the power 8 divided by the lambda minimum. So the only unknown over here is lambda minimum, and you just need to get it. Yes, some of you have got it. 0.31. Kya baat hai? Yes, I think that should be correct. Yes, 0.31. That's correct, guys. So it will be 0.31 into 10 to the power minus 10 meters, which is 0.31 Armstrong. Very good, very good. Yes, that's the answer, guys. Understood how to solve this? Very simple question. All right, these kind of questions do come in the examination. 0.31 Armstrong. How about this one? Something little bit more tricky. The wavelength of a characteristic X-ray K alpha line emitted by a hydrogen-like atom is 0.31. What is the wavelength of K beta by the same atom? Interesting. Let's see. Yes, Arjun, you could have also used 12400 electron volt to cancel that E. That is also possible. That is also going to make your calculations easy. So let's do this. Let's do this. Okay. Now, what is K alpha and what is K beta? If this is K, if this is L, if this is M, this is K alpha, this is K beta. This is n is equal to 1, this is n is equal to 2, this is n is equal to 3. Okay. Now, can I not use maybe this formula? Think about it. K alpha wavelengths I need to use. How about using this formula? 1 by wavelength. What is the wavelength? 0.31. Okay, is equal to some constant into 1 by this square, which is 1 by 1 square minus, so for K alpha the other n should be 2, so minus 1 by 2 square. So this is going to be constant 1 minus 1 by 4 is 3 by 4. So constant into 3 divided by 4. Just check this out if this makes sense. Okay. Similarly, the other wavelength, which I do not know, is going to be the same constant because the material is the same, very important, into 1 by 1 square, because from here to here the transition is happening. So from 3 to 1, only this number will change, 1 by 3 square. 1 minus 1 by 9, which is going to be 8 by 9. So it's going to be constant multiplied by 8 divided by 9. So now divide both of them and see what do you get. So 1 by 0.31 divided by 1 by lambda is 3 by 4 divided by 8 by 9. So lambda will go on the top, 0.31 will be below, and you will have 3 multiplied by 9 divided by 4 multiplied by 8. So that is going to give you the value of lambda. Just check it out. Just check it out. How much is the value you are getting? Come on guys, check it out. How much is the value you are getting? Just check it out. Is it going to be somewhere close to 0.26 Armstrong? Just check it out. Correcto. I think some of you have answered. No? Okay, come on, come on. Think about it. Very good, very good, very good, very good. Okay, so do that calculation guys. You're going to get it as 0.26 Armstrong. Okay, cool. Last thing of today's lecture. All right. And that is Mosley's law. Very important. Yes, 0.27 approximately. Correct, correct. Approximately you'll get that. No problem. Okay. Now, using 1 by lambda is Rydberg's constant into z square into 1 by n1 square minus 1 by n2 square, and substituting lambda as speed of light divided by frequency. If you rearrange this entire thing, oh sorry, this was z square. If you rearrange this entire thing, then Mosley got this law, which is root of frequency. This is same as frequency guys. So root of frequency is equal to some constant into z minus b, and for k alpha, this value of a, keep this in mind, yes, is root of 3 RC by 4, and this value of b is approximately 1 for k alpha. Now this is very important law which is called as Mosley's law, and for k alpha, what is the value? This is also something which you should remember for sure. So that proved that if you draw a graph of root of frequency versus atomic number, that came out to be a straight line. It comes out to be a straight line. Yes. Hello Hemang, this is of class 12th actually. No problem Hatem Ali, please watch the replay in case you have missed, and all those people who are joining late, please watch the replay out there. Yes, you can get a Nobel Prize rearranging an equation. Actually, he did not get a Nobel Prize for rearranging it. What he saw was, see, previously they used to arrange the periodic table based on atomic mass number. But he saw the characteristic X-ray is the same for different isotopes. See, the characteristic X-ray is the same for different isotopes of the same material. That means, since they are characteristic X-rays, think about it, they should be based on something which is more fundamental than the atomic mass number. And what is more fundamental than the atomic mass number? That is basically atomic number, and that's what he proved by drawing this graph. That, oh, when I arrange the atoms according to Z and not A, you get a straight line. And this law is obeyed. And that's how he rearranged the periodic table, and that's when he won Nobel Prize. I hope that's clear. Okay, cool. Yes. So here is the last question for today. Based on Mosley's law, let's think about it. The X-ray wavelength of L alpha for platinum is so and so. For L alpha for molybdenum is so and so. B is given. What is the wavelength of L alpha for molybdenum? Let's try to do this. So grades Gokul, what is the difference between characteristic? I can tell you many. Characteristic is a specific spike in the graph. Continuous is obviously continuous. For different each wavelength there is a intensity. Second thing, characteristic depends on target material, not on the potential difference, but continuous depends on the potential difference and not on the target material. Okay, and the method by which they are produced is also different. So you can watch how they are produced by just rewinding the lecture today. Hemang, yes, I had my dinner. Yes, thank you for asking. I hope, Hemang, you too had your dinner. Thank you so much. All right. So, well, let's do this problem, guys. The last question for today. So, let's use this. Root of f is actually equal to a into z minus b, but frequency is speed of light, all right, divided by wavelength. Hence, I can say 1 by root of wavelength is some constant. All right, this a and c is some constant, doesn't matter, into z minus b. Now let's use this. Let's use this. Okay. So here we go. 1 by, or I can just say, hold on, root of lambda 2 by lambda 1. Root of lambda 2 by lambda 1 will be equal to, think about it, that constant will go away, z minus b. So z1 minus b divided by z2 minus b. This is the relationship I'll get. Now you just need to substitute everything. So root of lambda 2 divided by lambda 1. What is lambda 1? It is 1.3, I believe, is equal to z1. z1 is 78. 78 minus b, which is 7.4, divided by z2. z2 is 42 minus 7.4. Now there's only one unknown. Solve this and you'll get lambda 2. Correct. Lokesh, only attending these lectures won't be enough. Hi Athav. You also need to put in your effort, beta. You need to solve so many problems, books, only then you will be able to do it. So you need self-study. Just attending lectures, nobody can guarantee, in fact. You know? Yes. Hi Athav, welcome. Okay, so solve this and you will get the value of lambda. Just check it out. If it comes out close to 5.41 Armstrong, that's what you will get. That's the answer. Cool. So using Mosley's law, 5.41 Armstrong. So I've kept some homework questions for all of you. Do check it out later on after the class is over. So I've kept all these homework questions out there. Okay, so do check it out. And the solutions also have been put. If you want these homework questions, the only way you can get it is by joining the Telegram group. So check out the description link below. There is the Telegram group link. Join it so you can download the entire PDF with homework and solutions and everything. All right, and do not forget. Hello Harsh, welcome. You're a little bit late. Maybe you can watch the replay as well. And all those 12th and the dropper students, remember, for all of you, we are going to revise entire 11th and 12th standard syllabus with 20 full syllabus test series and morning till night doubt sessions available for all of you to clear all your doubts instantaneously. And yes, all these things are going to start next week, Monday onwards. So do join in the crash course. Check out all the details again in the description box. And remember, the sale which is going on right now is 30%. So you will get 30% off on 10,000 rupees and the course is available for 7,000 when you use this coupon code SHCC. So do use it. Check it out, guys. The batch is next batch is starting on this Monday. And this sale is only valid for a few hours or a day or two maximum. So do use that. All right. So I hope you enjoyed this class. Bye-bye. Thank you so much. And tomorrow we are going to start nuclear physics at 7 o'clock. So see you sharp at 7 o'clock. And do not forget to hit the subscribe button in case you have missed doing so or missed hitting the like button. Go smash that like button out there. Bye-bye. Good night. Take care. See you.